11th. Today we will study the polar and non-polar bonds. Polar and non-polar bonds today we will study. Students, a covalent bond is formed. Covalent bond is formed by sharing of electrons. A covalent bond is formed by sharing of electrons. Now, if the two bonding atoms, or these atoms are homoatoms, that means homoatoms means these atoms have same electronegativity. If the covalent bond is formed between two homoatoms, that means the atoms having same electronegativity. For example, in case of hydrogen molecule, in case of chlorine molecule, these are homoatoms. Now this homoatom, for example, electron pair, shared electron pair. In case of hydrogen molecule, this hydrogen molecule in this electron pair is attracted equally by the two bonding atoms. With the result, this electron pair remains equidistant. It remains equidistant. Shared pair remains equidistant from the atoms, from the both bonding atoms. With the result, this bond is formed is non-polar. That means a non-polar bond, in case of a covalent bond, formed between two homoatoms, that the atoms having same electronegativity, electron pair is shared equally and electron pair is attracted equally by the atoms. With the result, this electron pair remains equidistant from the both atoms. This bond formed is a non-polar bond. Now, if a covalent bond is formed, between two different atoms, that means the atoms having different electronegativity value. Electronegativity, it is the tendency of an atom to attract the shared pair of electrons. If the atom is having different electronegativity value. For example, I will take the case of hydrogen fluoride. The covalent bond is formed between hydrogen fluoride. Now this electron pair, which is shared between the hydrogen and fluorine, this is attracted by fluorine more by the fluorine. With the result, electron cloud gets distorted and it remains near to the fluorine, and hydrogen is to some extent divide of this electron pair. With the result, the fluorine attains negative charge and hydrogen attains a positive charge. With the result, this bond formed is a covalent bond, but it's a polar covalent bond, because the two atoms are developing the two charges, positive and negative. This is called a polar bond. So a polar bond is formed when the two combined atoms are having different electronegativity. With the result, electron pair is attracted more by the more electronegativity is attracted more towards the more electronegative atom. With the result, with the atom having higher electronegativity attains a negative charge, and the atom with the less electronegative value attains a positive charge. This bond is known as a polar bond. For example, if I will take the case of hydrogen fluoride, this is the if you take this hydrogen electron cloud gets, this is the hydrogen and this is the fluorine. Now fluorine electron cloud gets distorted more towards the fluorine. With the result, this hydrogen attains the positive charge and fluorine attains the negative charge. This is called the polar bond. Now other examples of polar bonds are, for example, if we take the interhalogenous compounds. In case of interhalogenous bonds, or bonds are polar. For example, if you take in case of iodine fluoride, fluorine is more electronegativity and iodine is having less electronegativity value. Therefore, this bond is a polar bond. For example, a BrCl, bromine chloride, yeah, iodine chloride. These are the examples of these polar bonds. Now, for example, they may be noted in case of symmetrical. I will take the symmetrical molecules. If in case of symmetrical molecules, for example, carbon dioxide, for example, carbon tetrachloride, for example, methane, though there is electronegativity difference, but the molecule is symmetrical. In case of symmetrical molecules, for example, I will say it is CCl4, it is CH4, it is carbon dioxide, it is SF6, it is IF7. These are, in case of these are symmetrical molecules. In case of symmetrical molecules, though the bonds are polar, but these are having zero dipole moment. These are having zero dipole moment because these are symmetrical molecules. And unsymmetrical molecules, there are polar bonds. For example, these are for example, I will take the case of lithium fluoride. Lithium fluoride, I will say this ionic bond is a is ionic bond जो है, is an extreme case of a extreme case of a polar bond. For example, we say that a covalent bond is formed by the sharing of electrons, and in case of polar covalent bond, this electron pair gets distorted and remains with the more electronegative atom. In case of polar covalent bond, electron gets electron pair, that's electron cloud, I will say, gets distorted and it is attracted more by the electronegative atom, by the atom which is more electronegativity. In case if the electronegativity difference between the two atoms is high, if the electronegativity difference between the two atoms is high, between two atoms is high atoms is high, then this electron pair, it seems that more electronegative atom get us complete position of electron, more electronegative atom get us complete position of electron, get us complete position of electron, complete position of electron. So with the result, it seems that electrons are transferred. For example, I will take the lithium fluoride. In case of lithium fluoride, electron pair gets, fluorine gets more, is more electronegative, and it gets in complete position of this electron pair. So it is I will say ionic bond is an extreme case of polar bond. Now we can say, if the electronegativity difference is 1.9, is equal to the one, if the electronegativity difference between the two bonding atoms is 1.9, there is 50% ionic character and 50% this 50% ionic character, 50% color character. If the electronegativity difference between the two atoms is 1.9, the bond is said to be 50% ionic and 50% covalent. If the electronegativity is more than 1.9, that means electronegativity difference between the two is more than 1.9, then it is partial, there is a partial ionic character, in the bond. If it is less than 1.9, we say that it is a covalent bond. So we can say that from the electronegativity difference, we can say whether the bond is a covalent, or it's a partial ionic character, or it's a covalent, it's an 50% ionic or 50% covalent. If its electronegativity difference between the two atoms is 1.9, then it is 50% ionic and 50% covalent. If it is more than 1.9, then it is partial ionic character. If it is less than 1.9, it is covalent character. Now percentage of ionic character, we can say it is equal to, if we can determine, if we there is a problem, there is a numerical to find the percentage of ionic character, we can calculate it by, it is equal to 16 into chi a minus chi b. Chi a and chi a means electronegative of atom A and electronegative atom B, into plus 3.5 into chi a plus chi b whole square. Chi a minus chi b into chi a minus chi b whole square. I will repeat it. Percentage of ionic character is determined, it is chi a minus chi b, where chi a is the electronegativity of A, chi b is the electronegativity of B, plus 3.5 into chi a minus chi b whole square. We can determine by this equation this percentage of ionic character. Students, why we will study now what is dipole moment. dipole moment, we know a covalent bond. In case of polar bond, there are positive, and there is positive, one end is positive and other end is negative. That means, for example, in case of hydrogen fluoride, fluorine is negative and hydrogen is positive. So in case of polar bond, one bonding atom is having a negative pole and other is having a positive charge. That means there are electric dipoles. There are electric dipoles. So the electric dipoles are present there. That means it has dipole moment. Dipole moment is, it is the product, it is the product of, product of magnitude of charge, magnitude of charge. I will repeat it again. Since positive and negative charge are equal, so it is the product, it is a product of magnitude of charge and the distance of separation. That means what is the distance between the two, internuclear distance between the two bond atom. For example, if we write it is dipole moment by mu, then it is equal to Q is the product of the charge, positive and negative charge ka product, and D is the distance of separation. That means, that is bond length hogi, that is distance of separation between the two atoms, that is bond length. So q, if q is a 10 raised power minus 10 esu, that is electrostatic units, and distance is 10 raised power minus 8 centimeters, that is equal to 1 extra, and that is equal to, then mu is equal to 10 raised power minus 18 esu centimeters, then it is called 1 dpi. It is called 1 dpi. So this is the dipole moment, is the product of magnitude of charge and distance of the separation between the two atoms, between two charges, or between two atoms. Now in case of students, if we take case of a diatomic molecule, in case of diatomic molecule, it is a diatomic polar molecule. Since there is one polar bond, only one polar bond present. In case of diatomic polar molecule, there is only one polar bond. Therefore dipole moment is equal to the dipole moment of the single bond. It is called the dipole moment of the single bond. For example, I will speak HCl. This is negative charge, chlorine is negative charge, and hydrogen is positive charge. So dipole moment is the dipole moment of single bond, that is 1.03 dpi. And we must know this dipole moment is a vector quantity. It has both magnitude as well as dipole moment. It is a dipole moment. Is a vector quantity, but it has magnitude as well as direction. We represent it by a arrow, with the arrow head towards the more negative atom and arrow tail towards the less electronegative atom. For example, this arrowhead will go towards the fluorine and tail will go towards the hydrogen atom. By this we represent this polar bond. Now for example, in case of, if there is a bond between polyatomic molecules, if the bond is present between the polyatomic molecule, that means there's a polyatomic molecule, there are number of polar bonds. In case of polyatomic molecule, if there are number of polar bonds, then the dipole moment is equal to resultant dipole moment of all bonds. For example, in case of H2O, negative charge is positive, the dipole moment is equal to dipole moment of the two bonds, that is 1.84 dpi. For example, in case of NH3, dipole moment is, there are three bonds which are polar, the result dipole moment is equal to the dipole moment of all the three bonds. Is similarly NF3, dipole moment is equal to the dipole moment of all the three bonds. And in case of, for example, if we take the symmetrical molecules, for example in carbon dioxide BF3, since result dipole moment in all the BF3, the resultant dipole moment is equal to 0, because these molecules are symmetrical. Similarly in carbon dioxide, in case of BF3, resultant dipole moment is, because the dipole moment of each bond cancels one another's effect, so the resultant dipole moment is equal to 0. Now if we are going to calculate the dipole moment of, if the two bonds are inclined at an angle of one at an angle of theta. Let A, B, AC, these are two bond at an angle of theta. So that its dipole moment is 1 its dipole moment is mu2. So result dipole moment is equal to mu r is equal to, it is equal to under root of mu1 square plus mu2 square plus 2 mu1 mu2 cos of theta. Now if theta is equal to 0, if theta is equal to 0, the resultant is maximum. The resultant is maximum. And for example, then result dipole is equal to mu a plus mu b, mu1 plus mu2, or mu a plus mu2. If theta is equal to 180, then the resultant is minimum. Resultant dipole moment is minimum, because then it is mu1 minus mu2. This is how we can calculate the dipole moment of the molecules.